and that's going to be using a cross product. So what we're going to want to do is we have a reflection. Essentially, we have this blasting off the reflection angle, and that's fine. But what if I wanted to modify where the reflection is pointing? It's like right now we got it. Comes in, reflects out. But maybe I want to like say instead of reflecting out, maybe it should reflect up a little bit more also. And there's no reason why I shouldn't be able to do that. So let's move this over. So before it gets to do this whole part, let's change what the reflection actually is. Let's see. The cross product is how we're going to do that. And what a cross product does is, unlike the dot product, which takes two vectors and returns a float comparing the two, a cross product will take two vectors and give you the normal to the plane created by those two vectors. So what does that mean? Imagine you have a vector and another vector, and it looks like it forms a triangle. Well, it does. And that triangle is a flat surface, and that flat surface has a normal that points out perpendicular from it. That is what a cross product gives you, plain and simple. Another way of looking at it is if you have this vector and this other vector, the cross product is the hinge of sorts that you can rotate around to get from one place to the other. In our case, we have this reflection here, and if I take this up again, the up vector, if I cross those two, I get a hinge that will allow me to start to point the angle up towards facing straight up and down. So that's what I want. So I have this hinge, this returns that vector, which is the axis, so to speak, that it will rotate around. A quaternion is simply a way of representing an axis, literally, as you can see here, and also an amount that you rotate around that axis. So given our hinge, how much do we want to rotate around that hinge? And that's what this is going to say here. So I'll call this reflect rotation, or just reflect rotate. And that's what this is. This defines that rotation. And then all we have to do is take quaternion rotate, or rotate by quaternion, and hook that up here and say, this is the amount to rotate. The reflection is the vector that we want to rotate. And that is our new reflection. We just change that to here instead. So let's see if that does what we want. As you can see, nothing changed because essentially, as usual, this is initialized to 0. So the reflect rotate is not rotating any amount. But as I start to spin this, you can see now I rotated all the way around to the back. Or this is really more all the way around to the back. This is in radians, of course. So this is pi right now, or this is closer to pi, so that's all the way in the back. 0 is all the way in the front. So we can rotate this around and just give it different areas. Again, mostly we're going to want to use this for just like making it point up a little bit. So I'm just going to say like more or less what we already have actually. I'm just going to say maybe a bit, something like that. And there you have it. It's kind of pointing up a little bit more. I'm going to box this guy up too and say rotate reflection. And why not that? Cool. And so we end up with this. We've got extreme peaks, valleys, stuff blowing back towards the way it came, but mostly going this way. You can play with all this stuff if you want. This is probably what I'm going to keep here. Remember that ultimately we're really going to source everything from this here. This is, I should put our normal here. Let's have the normal here reflect, or like, represent what we ended up calculating. So there you go. That's what we ended up with. It's also stored in the velocity, which is more important. It's still hard to see. It's on the inside, but if we kind of go in, you can see it here. And that's what we want. And that's what we work towards in this whole chapter here. And this, like I said, is one of the most important parts of the lesson, is being able to visualize how to design something like this. I'm also going to throw a rest position on here, which we'll use later to color in our particles that we're about to create. This is basically going to store where the particle is sourced from. And by applying a noise to the rest position later on, we can consistently color in our particles. But we'll get to that shortly. So I'm just going to put this here. I'm going to say blast source. And this is going to be the source of our particle simulation.